Hello, Dr. Vels here. In a previous video I showed that I had constructed a end-fed half-wave tuned for the 7 MHz band, which works on the harmonically related bands and can be tuned slightly using an antenna tuning unit to cover the 10, 18 and 24 MHz bands as well, even the 50 MHz band. Well, since then I've had a few problems, mainly with the cheap RG58 coax that I used. I had to use an array of connectors and adapters to connect the end-fed half-wave's coaxial feed to a different cable coming from the house, as the original cable using the cheap RG58 had gone bad. The braid wasn't making sufficient contact, so I opted to change that. A few other things that I've changed since the last video are the Coaxial Choke, which was originally 8 turns of RG58 on an FT240-43 toroidal core. And after reading about Steve M7 SLR's experimentation, I've changed that for a 10 turn coaxial choke wound on an FT240-31 toroidal core, which should be better across the HF spectrum. I was unhappy with the value of the capacitor across the primary of the 49:1 impedance matching transformer. I'd used an 82 picofarad polystyrene capacitor. I did manage to get my hands on a 100 picofarad ceramic capacitor rated at 5000 volts, which should be more than enough for me running 100 watts maximum and should be sufficient for higher powers as well. I decided to change the screw terminal block, replace it with a 4mm binding post, and the idea was to mount all this in a box. The box I bought was a little too small. The capacitor and the binding post were interacting with the transformer, so I scrapped that idea and just mounted the 3 components outside as before. Later on, the binding post snapped off the wire from the transformer. The solder joint wasn't too great, so I ditched that idea and just went back to using a screw terminal. I stripped the insulation off the wire, which is only 0.5 mm thick, just to try to reduce visibility. It doesn't have a great visual impact, but it can be seen even though the wire is so thin. Both my neighbours have noticed the wire but don't mind it being there, thankfully. The button insulator that I used before has been replaced with a proper one from a UK supplier, and it seems a bit more substantial. The post at the far end, which is screwed to the shed, is a lot higher now. It's at least 4.6 metres high. This gives me a lot more height towards the end of the garden. The garden tapers off. It's almost a triangular shape, so that gives me a good separation distance from the neighbours, meaning that I can use a bit more transmit power on the higher bands. I've also installed a pulley because the previous arrangement didn't work, and now the pulley allows the tension to be maintained in the wire. There's also a guy line which helps to keep the post vertical. The line which feeds over the pulley goes down through an eye which is screwed to the shed and then down to the weight. If I want to do some maintenance on the antenna, such as alter its length or repair it, I can remove the weight from the end of the line and the carabiner will stop in the eye. This prevents the nylon line flying off the top of the pulley and then me having to thread it back through again. When the weight is released, the end of the wire, where the insulator is at a reasonable height for maintenance. That's purely by chance. I would like to say that was by design, but sadly I can't do that. But it's worth considering that point in any installation like this. Overall, the tension is maintained fairly well. It only failed when we had some significant snowfall towards the end of 2024, which was quite claggy, and it all settled on the wire and weighed it down quite a bit. I don't have a photograph because I had to go out early in the morning, but when I returned in the evening, the snow had melted and the weight and the pulley had done their job and the wire was back taut again. at the right height. So now the wire goes from 3 meters above ground level at the transformer up to around 4.6 meters at the far end. So it is actually slightly sloped, which should alter its radiation pattern ever so slightly. But just looking at the SWR plot on the Nano VNA, everything looks okay, and the 10, 18 and 24 MHz bands can be easily tuned even using the puny automatic antenna tuning unit housed inside the FT991A. Well, I hope you found that interesting. Hopefully it will give you some ideas when you construct or modify your wire antennas outside. Thanks for watching and see you again. Bye.